Hello, and thank you very much for joining this presentation about the Tool Qualification Kit for Testwell CTC++ Test Coverage Analyzer. My name is Klaus Lamberts. I am co-founder and CEO of the company Verifysoft Technology. So before we start and go into the details of the qualification kit, first some information about Testwell CTC++. Testwell CTC++ is a leading code coverage analyzer for embedded software development. The tool analyzes for all coverage levels up to MCDC and multi-condition coverage. What are the unique selling points of Testwell CTC++? There are a couple of very interesting things for our customers with this tool. First, Testwell CTC++ works with all compilers and all cross-compilers, and thanks to the bit coverage analysis and the low instrumentation overhead of the tool, it works with all embedded targets. So whatever you have with CTC++, it works. So many of our customers compare Testwell CTC++ to an off-road vehicle. It goes everywhere. Whatever you have, even if you have some strange development, Testwell CTC++ will handle it and analyze the good coverage of it. So Testwell CTC++ fulfills the requirements of safety standards like DO 178 and ISO 26262. And for this reason, it is used in hundreds of safety critical developments. In order to prove that Testwell CTC++ works properly when used for safety critical software, we have developed the CTC++ qualification kit. Such proofs are demanded by standards, so the qualification kit can help you to certify your project. By the way, there is a difference between certification and qualification. There are some tools which claim to be certified, but please attention here. Certification means that the certification is only for the exact environment where the tool has been certified for. So it's very unlikely that you have the same environment in your company. So for our customers, the tool qualification kit is much better because they can certify their specific project with the qualification kit. So with the qualification kit, Testwell CTC++ can be certified for your project for whatever you have environment. The Testwell CTC++ qualification kit has been developed in cooperation with the company Validas from Munich. Validas is expert for this kind of qualification and certification, and the following presentation is a recorded WebEx of Dr. Oskar Slotosch, which you see him here in the picture, and Oskar will explain you how qualification is done. So let's first have a look to the content of this video. In part 1, Oskar will explain you which tools need to be qualified. This is a software tool classification, so you need to classify the tools in your tool chain to see which of them needs to be qualified and which needs not to be qualified. In part 2, we will talk about the tool qualification process. This means how the tool qualification is done. And finally, in part 3, we talk about the tool qualification kit for Testwell CTC++. So we will see what is part of the kit and how to use it. So let's start then with the tool classification. We will go directly into the web presentation of Dr. Oskar Slotosch now.
I'll present you a little bit on what is in the CPC Q kit, but I think it's better to understand first the overall method and the needs, why we do have what the ISO is intending to, and how we can satisfy it. Now let's come to the motivation and the processes. Well, the main motivation is that you do have something like this in your tool chain, so addition that instead of adding 1 to 1 to 2 is generating code that equals 1 and 1 is 0. And this might cause your car to crash. Let's come to the requirements. So the standards are very similar, and we do differentiate 3 different processes. So the first process is the tool chain analysis, which all users, so OEMs, but also providers, they have to analyze their tool chain. And tool chain is all tools that they need, that they need for development of safety relevant software. So this is typically a big tool chain, and some of the tools are critical. Well, you may call them TCL2 or TCL3 tools, but some of them are in a sense critical that they can have impact on the safety of the product. And those critical tools we mark here as red. So the tool chain analysis says those tools are critical. The uncritical tools can be used safely, but the critical tools have to be qualified. And that's the second process. That is the qualification. So you take a tool which is critical, a red tool, and then you apply a qualification kit, then you get all the documents you need, and then you can use maybe some error reports that you have to work around, but then you can use the tool safely. So first the tool is red, and then the tool is green, and the magic occurs within those qualification kits, so that you can trust the tool. And the ISO 262 has a chapter on the confidence in the use of software tools. This is in part 8, chapter 11, and this requires to analyze the tools in 2 steps. So first is we think whether the tool has an impact or not. So Excel might have an impact if it's used in the development for specification or tracing or whatever, or if Excel is only used for the calculation of costs, then it has no impact. And tools with no impact have TI1 and they are uncritical. Tools with impact have to be analyzed further. So if you say, well, I have a testing tool, and the testing tool cannot insert errors into the product, but they can fail to detect some of them. And therefore they are critical in principle. And for those tools with an impact, you have to think on all potential errors in the tool. So the tool might crash, the tool might produce wrong results, the tool might give wrong warnings, whatever. You have to think on every potential error, and then think on the mitigations that you have. Either you can prevent this by saying, well, I don't use this feature in this way, or I'm very careful, or you can detect these potential errors that occur. So if the tool would crash, I would detect this because I'm using it interactively or whatever. So you have to think on every potential tool error and then decide if there's a high, medium, or an unknown or low detection probability. Well, and if you have a high detection probability for all tools, then it's TD1, so you have the best possibilities to detect all potential tool errors. So for example, if you do have 2 compilers, 2 platforms, and you have your software, you do your target testing on one platform and on the other platform, then you have a very high rate to detect compilation errors in the compiler. So that's a very high probability. If you do a mill-based simulation and then just compile and flush the code into the target without testing it, then you have very low detection probability of the potential error that the compiler is wrong. And well, here on the right-hand side you see the table how to infer the TCL. So TCL means tool confidence level, and there are 3 levels. TCL1, which is if you have either no impact and everything is TCL1, or if you have TD1, so you have a high probability to detect it. So TCL1 tools are uncritical tools and don't need to be qualified. For the TCL2 and TCL3 tools, you need to qualify the tool. And the ISO 262 describes different approaches for qualification of tools. So here you see the TCL3 methods to qualify a tool. So you can, for ASIL A and ASIL B, you can argue with an increased confidence from use. So I'm using this tool with a version 1.0 since 3 years and in several projects, and it always works. So it will be good also for the next project. Okay, this is a little bit the relationship to other standards. I will go only very briefly. So you see the ISO 26262, and the first question was impact, and if there's no impact, then TCL1, and if there's impact, depending on the TDs, you have high, medium, and low, then you get TCL2 and 3, and then you have the different qualification methods. Well, for the other standards, it's similar. You get some classification in the DO. It's called criteria 1, 2, and 3. And for the EC and the EN, it's called T3, T2. And the higher the criteria, the more you have to do. And T1 is uncritical. In the EC case, the DO case, it's also similar. Criteria 3 comes to TQL 5, and this is not so much to do. Why you should do a tool chain analysis instead of a user? Of course, you are flexible. You can say what is if we replace some tools, or what is without this tool. So that's something you can do very good on a model-based approach. And another thing is, if you have a big tool chain, you have a high probability that one error of one tool is detected by another tool. So you have some redundancy in the tool chains, and you can say, you can argue with this, and this reduces the tool criticality of all tools. There's one important thing, that the outcome of the tool chain analysis does not depend on only on the tool. It mainly depends on the process. So if somebody asks you which TCL has the tool, you can only respond, it depends on how you use it. If he is using it in a safe way with redundant checks and can detect all potential errors, then he is TCL1. My favorite example, and if not, this might be TCL2 or 3. My favorite example is Make. Make is a simple build tool, and if you just say Make, when you have fixed a bug, and Make would oversee as a potential error, would oversee the dependency and would not recompile your fixed source code, then the bug will remain in the product, and this is dangerous. And therefore Make has TCL3. If you're using it, let's say, in this way. Well, typically experienced developers know that they have to make a Make clean and then Make. And if Make would have the potential error to oversee some dependency, it would fail to build the target again. And therefore, using Make together with Make clean is safe and TCL1. And this is the difference. So you see that they are, depending on the process, you can have TCL1 or TCL3 for the same tool. And you see also that the process for having a TCL1 is a little bit more work. So even if it's just a command, Make clean, you might have to wait some seconds, minutes or hours for this Make clean and Make again. So there is more work, there is more time to spend, and exactly this overhead you have is the benefit of tool qualification. So if you would have qualified the Make, then you do not need to say Make clean. Yeah. Well, now we come to the what is a little bit inside and how we do the tool qualification. And as I said, it is very important to have a tool safety manual to use a tool safely. So in the sense of that there cannot be any errors that affect the product. And what are the contents of the tool safety manual? And what we do, as you remember, we classify the potential errors, TCL1, TCL2, TCL3, all potential errors are analyzed. And when you see here the set of all potential errors, there are three subsets, and one are the errors in the unused features. So if you have a disassembler in the compiler suite, then you say maybe the disassembler is not so interesting because I don't use it. So then the errors in the unused features are something you don't care. However, you have to write into your safety manual, don't use a disassembler, because otherwise the classification would be wrong and there might be potential errors. So there you have a restriction not to use the disassembler, and that's something to put into the tool safety manual, because you said we don't consider it. The next thing are the detectable and avoidable errors. So if the tool crashes, you will notify this. Therefore you have to add to tool safety manual, please check for tool crashes. Well, that's probably so silly you don't need to write, but in principle those is something important and to put there. And more difficult are those remaining potential errors that you are in the features you're using and that are that are not so easy to detect. And for those you do create a tool qualification plan. And this tool qualification plan aims at showing the absence of those potential errors. Well, you do this by validation, but the main goal is to show the absence of those, we sometimes call them critical potential errors. Well, then you run the qualification somehow, I will come to this later, and then you get a tool qualification report that says, well, the tool is basically okay, but we do found some one or two smaller issues. For those smaller issues, it's easy to have workarounds, but we didn't found anything else. And these workarounds you can put to the tool safety manual, maybe together with some known errors that also need some workarounds that might occur also in the tool qualification report when the error occurs and it's known, so it's very likely. So this is somehow the principle that is and shows out what you documents you need. You need a tool classification report, you need a tool safety manual, you need a tool qualification plan, and a tool qualification report. And those are 4 documents which are important. And well, don't be afraid. We won't urge you to write 4 documents. We do have a document generator for this, and that's the benefit of the model-based approach, to have there a flexible thing that depends on how you're using the tool. When you go to the TÜV and ask for a certificate, they will say what is your exact use case and what is your exact tool safety manual, and then they will have a look to your tool qualification for this use case, and then they will certify you that you can use the tool exactly in this use case, so the tool is fit for purpose. Well, now let's come to the qualification by the validation. So how do the Q-Kit look like? And we look to the ISO 262, and it has a very simple description what qualification by validation means. It means the tool shall comply with the specified requirements. Well, and what does it mean, specified requirements? Those are the required features that you're using in the use case. So if you are using MCDC code coverage, then the tool should really measure MCDC code coverage. And if you are using code exclusion, then the tool shall really exclude the code. So those are the specified requirements, and complies means does not have the critical errors. So we don't need to check for all things. For example, for code exclusion, we have a very simple mitigation, which means if the code is not included, you will notify this. So look for included code, and therefore we don't have any critical errors there, and compliance is very simply proved. So that's something which is the validation. This is now the main slide for showing the contents of the Q-Kit. So the first slide you already know, so we have this tool safety manual that we need to create, a tool qualification plan, a tool qualification report, and we do this by testing. So we do have for each feature that we do select, we do have either mitigations that can go here in the safety manual directly, but for the other remaining features we do have test cases. And if you do have a test case and the feature is selected, then this test plan will be executed and you will get a test report that can be analyzed. So this is done using testing, and we have a test automation unit that can execute test cases, and not only in your development side, of course you do test cases there, but also on the user side. So with the qualification kit, you deliver this test automation unit that the user can run the test in his environment and really see whether it's working in his settings. So that's something which is also in the QKit contained. There's this qualification support tool I'll show you next slide. And of course there are some user manuals and templates inside. And one thing is very important, so why can we trust this QKit, is a V&V report. So Klaus will remember the pain in going through all the V&V checks that we had, like probably more, Olavi will
Olavi remembers more, yeah.
Because, for example, if you have a compiler and you have a test case, you can argue, test case is called Hello World, and you can argue that the Hello World will show the absence of all potential errors in the compiler. Well, for the formal view, this would be okay. So I would say every critical error is detected by this, and I can generate you very nice reports documenting this. The only issue is that Hello World will never detect all errors of the compiler, and this is the most important verification task. So that I do ask, is the test really suitable for showing the absence of an error? Which, of course, for test is a hard thing, and we need to have a test strategy to document this, and that's something we did develop for a CTC tool, a test strategy, and that we can believe in showing the absence. For example, we are looking to the grammar of C, and we are looking to all cases where coverage can be measured, and we then create a test case for all those situations. And for multi-conditions, we generated terms up to the size of 20 terms to have random combinations and other combinations of terms in order to show that the multi-condition coverage is working correctly. So those were, for example, the test strategies we developed, and then we did a successful V&V that we can say, well, these are really good test cases. And that's something that people like when they have the QKit. They would like to see, can you show me the test cases? What are test cases are in? And did you detect something with it? Those are the questions that to create the confidence into those QKits that they can really see. Well, that's I think the qualification kit. Now I show you the qualification support tool, which is here you first select the standard, which is important for you. Then you can select the different variants, so might be using target tests with BitCup, or you might be just test on the host. And if you're just doing host tests, then the target testing features of CTC will not be displayed to you. And you can select the tool, and you might select some versions of the tool, and then you come to the point where you select the features. And the features can either be green, which means you have testable test cases for it, or it can be pink, which means you have to do some mitigation. So, and then you select the features, and for those which require mitigation, in the next dialog you have to select the mitigations. And they are displayed here in this explanation, so it's quite easy. It's like an installer that guides you through this qualification. And at the end, you can do a little planning and then generate the required documents. The tool qualification plan, tool safety manual, tool classification report, everything is generated after those few selections.
So the green ones are features where you have already developed convincing test cases, right?
Yes.
And the pink ones are things where you don't have test cases, but they are mitigations. Does this mean you have to describe some restriction, how to use it, or what is that?
Exactly. So we have mitigations that describe restrictions, how to use it. It fits for many purposes. You know what this means, and it covers the C language. It contains over 50,000 test cases. So we had really, and I think most of the test cases were new. So we developed together with Verifysoft some of them, and Validas also contributed some of the test cases. Most of them because we have test case generator, and well. The QKit contains, of course, the user manual, qualification support tool, test cases, this test automation unit that needs to be adapted that it can run the CTC test cases. So we do have a generic test automation unit that we just adapt parts of them to call the specific tool and to provide the configuration. And when you buy the kit, it also contains, of course, the V&V report and 8 hours of qualification support. So you get some WebExes from us as this one, and we help to select the features or to analyze some findings, whatever. And this is somehow quite detailed. You get this qualification support tool in the zip file from our SVN, and you have you execute the qualification tool support, and that's now the screenshot from the CTC tool. You select the target directory like during the installer, and you select the standard, you select the tool, the version. Now we have the use cases here, a little bit more detailed with the explanations, and you have the mitigations that you can select. And if you don't select all mitigations for all potential errors, you can continue. So this next button will only be enabled when everything is selected correctly. Of course, the default configuration is something where you can press next, so you don't need to think on it. You can just go through it. So this is the planning component. You can say who is your safety expert and has to do which tasks during tool qualification. The process is described, and those are the steps. You can say we do this today or tomorrow or next week, whenever you do a little bit of planning, because the tool qualification plan is really a plan, not only a list of test cases. And you can document where you store your artifacts, and when you archive the tool qualification, everything is fine. You get a summary and generate the documents. And next step is then, you can see here the test plan with a list of test cases, and you update the documents and review the documents, and then run the test cases. So test cases, I can show you just the last slide. Here you need to configure the GRE, and then you can configure these CTC specific options. So you can also run manual test cases, because it might be necessary to flash the code manually, but typically we prefer to do it automatically. And you have some compiler commands you can enter, because CTC supports several compilers. You have the instrumentation option that is set here, and once you have set all those things, then you can just start the test cases from your command line and run tests. The test list you give provided an argument and the tool configuration, and then you will see here the different tests are executed, and at the end you see here those are the build folders, which shows test results as they have been provided in case you need to analyze something, and you get a test report. Of course, this is here just a short one from the development, but you get a test report that shows you what failed and what was okay. And you can analyze them and see the log files and whatever. You can find different reports and see differences, and you can analyze them with SVN, and here you see that the version number changed, and that the number of executed test cases changed, but important that the test coverage did not change. And even if the test says it has been failing because due to some version changes, you can still argue, well, the coverage is the expected one, and therefore the tool is qualified. And those are a little bit manual steps you need to do when you write your tool qualification report. You go through all of those steps and say, well, they are passed, and even if they fail, they are okay, because the main information is TCTER, which is the coverage, and this is okay. Well, that's, I think, everything to know on the CTC qualification kit from its abstract point of